Good day to everyone. For this tutorial video, we are going to tackle about the lessons for the final term in STM 112 Basic Calculus. The lessons we are going to discuss are the following: differentiability and continuity, differentiation rules, higher order derivative, chain rule of differentiation, extreme value theorem, implicit differentiation, and related rates. Now let's first identify the relationship between differentiability and continuity. The definition states that if a function f is differentiable at x sub 1, thus the function is continuous at x sub 1. Meaning, if a function has a derivative or differentiable, then it is continuous at the given number or at the given point. Now, what if the function isn't differentiable or is not differentiable? Okay, so if a function is discontinuous, therefore it is not differentiable and we cannot find the derivative of that function. So a function f can fail to be differentiable at a number c for one of the following reasons. So, reason number one is that the function is discontinuous at c. Now, as you can see in this graph, this is obviously discontinuous as the limit does not exist. And also recall that to be able to find the differentiability of a function, we use the limit. So if the limit does not exist, therefore a given function is not differentiable or there is no derivative. So in this case, this first graph right here is not continuous and therefore is not differentiable. The second reason, the function f is continuous at c and the graph of f has a vertical tangent line at the point where x equals c. As you can see in the second graph, although this graph is continuous, but however, the limit does not exist. And also we cannot find the tangent line of this because the tangent line of this in this graph is at the point in the middle. So there is no tangent line in this case. Now for reason number 3, the function f is continuous at c and the graph of f does not have a tangent line at the point where x equals c. Now for this third graph, as you can see, there is a sharp turn. There's a sharp turn over here in this graph, which means there's no tangent line. So therefore we cannot find the differentiability of this function. Now in order to find if a function is differentiable and is continuous, we use the definition of a one-sided derivative. So when we say one-sided, we are going to find the derivative of a function from the left to the right. And so if the limit exists from the right, positive, from the right, and the left, negative, then therefore a function is differentiable and is continuous. Again, if the limit exists, if a function's limit exists from the right and the left, therefore the given function is differentiable and is continuous. So this is the formula for finding the limit of the derivative of a function. So let's go over an example. So example number 1, determine if the function is differentiable and continuous. Let's see f of x. This is a piecewise function. So we have two functions over here. So first function is x, and the condition is x is less than or equal to 1. The second function is x cubed, and the condition states that if x is greater than 1. So first, if we're going to determine if the function is differentiable. So given the formula earlier, we're going to substitute the values here. So f of x. So first, we're going to determine the limit from the right. So from the right, we are going to use this function, the second function, x cubed, as the condition states that x is greater than 1. X cubed minus 1. So where did we get 1? Or how do we know if the f of x of 1 is 1? So what we're going to do is substitute this value, x with this value. So x 1 cubed which equals to 1. So negative 1. Also here, we are just going to keep or remain x as it is, minus 1, which is x of 1, which is this one here. Now we're going to simply cancel the negative 1 from the numerator and the denominator, and all that is left is x cubed over x. Now, after that, we're just going to cancel x from both the numerator and the denominator, and what's left is x cubed from the numerator. Now x cubed, how do we determine the limit of that? We are going to substitute x as x approaches 1. So x cubed, x squared is 1. Limit of 1 is x. That is 1. And so the limit of this function from the right is 1. Now from the left, it's the same. We are going to substitute f of x. Now we're going to use the first function as from the left, and the condition of the first function states that if f is less than or equal to 1. And f of x of 1 is just the same. We use this. X cubed is equal to 1. Here as remain x as it is, negative 1, which is this. The x of 1 is, you get this right here. Now we're going to cancel negative 1 from both numerator and denominator, and all of that is x over x. Actually, you can cancel this x minus 1 from the numerator and denominator, not just the negative 1, but x minus 1. And that is 1. And so the limit from the left is 1 as well. And so we can conclude that the limit of the derivative from the right is equal to the limit of the derivative from the left. Now, after determining that the function is differentiable, we are going to determine if the function is continuous. So remember the first lesson of during NVDA of STM 112. To determine if a function is continuous, there are three conditions. The first is that f of c pertains to a given number or given point, is equals to x, and the limit of x as the limit is x, and that the definition is that if f of c equals the limit of f of c. First condition, we have x as 1, you can see it from there, in the condition, for the first function, so x is 1, and then second function, so we're going to substitute x with 1, as stated here in the condition, and so x cubed is 1. We can say that f of 1 is 1, and now we're going to find the limit of f of x as x approaches 1 from the left. So we're going to use the first function as the condition states that if x is less than or equal to 1 from the left. So x is 1, so the limit from the left is 1. And now the limit of f of x as x approaches 1 from the right, we're going to use the second function as stated here in the condition. Substitute x with 1, x cubed is 1, so the limit of x as x1 as x approaches 1 from the right is 1. And so we can conclude that the limit of f of x as x approaches 1 is 1. And this also satisfies the third condition, as f of 1 is equal to the limit of f of x as x approaches 1. And for the whole example, we can conclude that f of x is differentiable at 1 and is continuous at 1. Another example is this one. Just same of the first function. The first function is x cubed minus 3. If x is less than 2, and the second function is fx or x minus 7 if x is greater than or equal to 2. Now, first we are going to determine if the function is differentiable. So first is from the right. So substitute so function for f x is just 1, as the solution states that x is greater than or equal to 2, so on the left. So that we use the second function here. The negative 1, how would we find the f of x sub 1? So we just substitute x with 2. So 4 times 2 minus 7 equals 2. So 4 times 2 is 8 minus 7, so we have 8. Sorry. 4 times 2 is 8 minus 7, so 8 minus 7 is 1. So negative 1 as stated in formula. Negative 1. And then x still remains x minus 2. So x of 1 is this again. X of 1 is just this. But for here, since this is a function of x of 1, we substitute the x of 1 to this function, to its corresponding function. And so after that, we are going to minus to solve the constant. So negative 7 minus 1 is negative 8. After that, we can in the next part, we are going to cancel, or not cancel, but since these are constants, the negative 8 and negative 2, they can be regarded as 0. Or the derivative of a constant is 0. So 0, 0, 4x over x. And then we can just cancel the x. We just cancel the x, and all that is left is 4. And so the limit is 4. The limit from the right is 4. Now from the left, it's the same. Now we're going to use the first function, as the first function states the condition. So the first function states that x is less than 2. So from the left, less than 2. So we can use the first functions, x squared plus 3 minus 1. Just the same thing. The function, the f of x of 1, we're just going to substitute x with the x of 1. So just 2 squared plus 3. 2 squared is 4 plus 3. Oh no, it's minus. So 2 squared minus 3. So 4 minus 3 is 1. So we have 1. And then use the same denominator. X minus 2. The x of 1 is 2. Again, the x of 1 is this over here. The given point, given number. Then we're going to minus solve the constant. So 3 minus 1 is 2. we can just cancel. We just cancel -2 from both the numerator and denominator. All that is left is x squared over x. Then we can again cancel the x. All that is left is x from the numerator, x. And then since there is no real number, we are going to substitute x with 2. And so the limit from the left is 2. You can conclude that the limit from the right does not equate to the limit from the left. Now that we have concluded that this function is not differentiable, we're still going to determine if this function is continuous. Okay. So f of 2 is equals to x squared minus 3. So we're going to use the first function first and substitute the x with 2. So 2 squared minus 3, that is equals to 4 minus 3. And 4 minus 3 is 1. Then we're going to use the second function f for x minus 7. Substitute x with 2, so 4 times 2 minus 7, that is 1. So it satisfies the first condition. Now, going to the second condition, we're going to determine if the limit exists. So first function x squared minus 3 is the same, substitute x with 2. So 2 squared minus 3, 4 minus 3, supposed to be 4. Minus 3 is 1. The limit of f of x as x approaches 2 from the left is 1. Now from the right command, we're going to use the second function as the condition states that x is greater than or equal to 2. So substitute x with 2, so 4 times 2 is 8 minus 7, that would be 1. So the limit of f of x as x approaches 2 from the right is 1. Which means that the limit exists and the limit of f of x as x approaches 2 is 1. And this also satisfies the third condition. So f of 2 is equal to the limit of f of x as x approaches 2. Now the conclusion for this example, example number 2, is that therefore f of x is not differentiable. I'm sorry, that mistake. Is not. Therefore, the second example or the second function f of x for the second example is not differentiable at 1. Again, the conclusion for this full example is that f of x is not differentiable at point 2 and but is continuous at 2. But so again, f of x is not differentiable at 2 but is continuous at point 2. Now let's move on to the differentiation rules. So the first rule is the constant rule of differentiation. This rule states that if c is a constant, if f of x equals c for all x, then the derivative of the function equals to 0. Which basically means that the derivative of a constant is 0. So for example, f of x is equals to 0, then we're going to find the 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 derivative of 7 that is 0. So the next rule is the power rule for positive integer powers. This rule states that if n is a positive integer and if f of x equals to x raised to n, then the derivative of that function is n times x raised over n minus 1. For example, f of x equals to x raised to 9, raised to the 9th power. And so what we're going to do is bring down 9 as a constant. So 9 times x. And then we're going to minus 1 from 9. So 9 is minus 1. So again 9, bring down 9, and we're going to minus 1 from 9. So that is going to be 9 times x, so 9x raised to 8, the 8th power. Since 9 minus 1 is 8. Next rule is the constant multiple rule of differentiation. So this rule states that if f is a function, c is a constant, and g is the function defined by g of x equals c times f of x, then the derivative of x exists by this formula. The derivative of x equals to c times f of x. So basically, with the constant multiple rule of differentiation, it's just the same like the basic law. Also, yes, this differentiation rules is similar or not the same with the basic laws as what we've learned during our midterms. So what we do is we separate the 2 from the x, and then as you can see, this is a positive integer power, so x4, so we're going to utilize the power rule for positive integer powers. And so that is to bring 4 here as a constant, and then minus 1 from 4. So 4 times x raised to 4 minus 1. And so that we're going to multiply 2 times 4, so that is 8, and then 4 minus 1 is 3. And so the derivative of 2x to the 4th power is 8x cubed. Again, we are going to separate 2 from the x raised to the third power, and then utilize the power rule, and then multiply 2 to 4, and minus 1 from 4, that is going to be 8x cubed. Next rule is the sum rule of differentiation. This rule states that if f and g are functions, and if h is the function defined by h of x equals to f of x plus g of x, then if the derivative of x, then if sorry about that, then if the derivative of f of x and the derivative of g of x exist, then we have this formula. So derivative of f, the derivative of h of x is equals to the derivative of f of x plus the derivative of g of x. So basically, what we're going to do is to find the derivative of each term. Okay, so we have five terms, 7 x raised to the fifth power, negative 2 x cubed, 9x squared, x, and negative 5. So derivative of x, the derivative of 7x raised to the fifth power plus derivative of negative 2 x cubed plus the derivative of 9x cubed, 9x squared plus the derivative of x plus the derivative of negative 5. And so, derivative of x of 7 x raised to the fifth power is, we're going to utilize the constant multiple rule of differentiation as well as the power rule for positive integers. And so 7 times 5 is 35, and then we're just going to minus 1 from 5, so 4. So the derivative of 7x raised to the fifth power is 35x raised to the fourth power. Again, the rule we utilized for this specific term is the constant multiple rule of differentiation as well as the power rule for positive integers. Then for the second term, negative 2x cubed, the same as the previous term. We're going to multiply negative 2 and 3. So negative 2 times 3 is negative 6, and it's going to minus 1 from the exponent or the power. So the derivative of negative 2 x cubed is negative 6x squared. Now, we're going to find the derivative of the third term, so 9x cubed, because as the previous two terms, we'll utilize the constant multiple rule of differentiation and the power rule for positive integers. So 9 times 2 is 18, and 2 minus 1 is 1. And so we don't have to put the exponent 1, which is going to be x. So the derivative of 9x squared is 18x, and then the derivative of x is 1. Utilized here is the constant multiple. Yes. Or any variable, the derivative of any variable such as x, y, h, g it's going to be 1. And now and now we're going to find the derivative of the last term, which is -5, and it's based on the constant rule of differentiation. -5 is 0. Since there is no variable, it's just a constant number, the derivative is 0. And so, the derivative of f of x is 35x raised to the 4th power minus 6 x squared plus 18x plus 1. Next is the product rule of differentiation. Now this rule states that if x and g are functions, and if h is the function defined by h of x equals to f of x times g of x, then if the derivative of f of x and the derivative of g of f exist, then we are given by this formula the derivative of h of x equals to f of x times the derivative of g of x plus g of x times the derivative of f of x. In an example, so we have this f of x is equals to 5x squared minus 4x times x raised to the 4th power plus x 8x cubed. Now what we're going to do is write f of x, which is 5x squared minus 4x times the derivative of the second function, or the second term. So what is the derivative of x for x raised to the 4th power? That is going to be 4x cubed. Again, the rule that we applied is the constant multiple rule of differentiation, and as well as the power rule for faceted integers. So 4 times 1, 4, and then 4 minus 1 is 3. So 4x cubed. And then the derivative of the second term, just the same here, x 8 times 3, that is 24, and then 3 minus 1 is 2, so 24x squared. And then plus, write the function of g of x, so x4, x raised to the 4th power plus 8x cubed times the derivative of the first function, the derivative of f of x, that is the derivative of first term, 5x cubed, is 10x. So 5 times 2 is 10, then 2 minus 1 is 1. So x raised to the 1st power is just x. So 10x. And then we're going to find the derivative of the second term in the function. So 4 times 1 is the 4, and then 1 minus 1 is 0, so that's gonna cancel out the x. So the derivative of negative 4x is just negative 4. So the next thing that we're going to do is to multiply this term to this term and this term. Okay, so 5x squared times 4x cubed. So that is going to be 20. So 5 times 4 is 20. And then we're going to add the exponents of the variable x. So that is going to be x raised to the 5th power, or x5. So we're going to multiply these two, right? So 5 times 4 is 20, and then we're going to add the exponents of the variables, which is going to be x raised to the 5th power. And then after we multiply this, 100. So we're going to multiply this to this, which equates to this term here, and then we're going to multiply this to this. So 5 times 24, we have 120, and then we're going to add the exponents of the variable x, as they have the same variable. So we're going to add those, so that is going to equate to x raised to the fourth power. So again, x raised to the 4 is 120, then add the exponents of this x variable is going to be x4. So 120x raised to the fourth power. And then this just the same for this second term here in the first function. So we are going to multiply negative 4x to 4x cubed. That is going to equate to negative 16x raised to the fourth power. And then we're going to multiply negative 4x to 24x cubed, and that is going to be negative 96 raised negative 96x cubed. We just multiplied negative 4 to 24, so that is negative 96, and then we will add the exponents of the x variable, which is x cubed. And just the same for these functions, we're going to multiply x raised to the fourth power to 10x, that is, which equates to 10x raised to the fifth power, and then we're going to multiply x to the fourth power, and we're going to multiply x raised to the fourth power times negative 4, that is going to be negative 4 x raised to the fourth power, and then x, and we'll multiply this 8, change the color. So 8 times 8x cubed times 10x, that is going to equate, that is equals to 80x raised to 4, and then multiply 8x cubed to negative 4, that is equals to negative 32x cubed. Okay, so now I'm just going to multiply the constants, and then add the exponents if both the terms have the same variable. And now we're going to add or minus the same variables. The same terms. We're going to add or subtract the same terms. So as you can see, we have the same term of x raised to the fifth power. So we are going to, first things first is to remove the parentheses and apply this positive symbol here to this specific function term. So that's going to be 10x, positive 10x raised to the fifth power. Okay, I didn't mention that. Okay, so again, we're going to subtract or add the like terms. And so we have 20 and 10, so 10 is positive, so 20 plus 10, that is going to be Okay, I get confused. So again, back here. So we're going to add or subtract the like terms. So in this first parenthesis, we are going to subtract. We have the same. We have the like terms. We have two terms for the like terms x raised to the fourth power. So we're going to multiply 120. We're going to 16 from 120, and that is going to be 104 x raised to the fourth power. I'm sorry for the misunderstanding. So again, we are going to subtract the like term of x raised to the fourth power. So that is going to be 104 x raised to the fourth power. And then same here in this parenthesis, we have the same like term of x raised to the fourth power. So we're going to add negative 4 to 80. So negative 4 plus 80, that would equate to positive 76. And after that, we're going to remove the parentheses and apply this positive sign to this terms here. So now we have 20x, positive 20x raised to the fifth power plus 104 x raised to the fourth power minus 96x cubed plus 10 x raised to the fifth power plus 76x raised to the fourth power minus 32x squared. And now we're going to do the same. We're going to subtract or add the like terms. And now we have, first we have x raised to the fifth power. So we're going to add the like terms. So we have 20 plus 10. That's going to be 30 x raised to the fifth power. And then for this to add 104 x raised to the fourth power plus 76 raised to the fourth power, that is equals to 180 x raised to the fourth power. And also here, we're going to subtract negative 6x cubed to negative 32. We're going to add negative 96x cubed to negative 32x cubed, which is equals to negative 128x cubed. So again, product rule, we are going to follow this formula. So write the first function times the derivative of the second function, then plus the second function times the derivative of the first function, and then we're going to combine the like terms, add or subtract, and then remove the parentheses and apply this sign to this function here, and then again combine like terms until we have the final answer. So for this function, the derivative of this function is 30x raised to the fifth power plus 180 x raised to the fourth power minus 128x cubed. Did I say that right? So again, the derivative of this function is 30x raised to the fifth power plus 180x raised to the third power minus 128x cubed. Second, another rule is the quotient rule of differentiation. So this rule states that if f and g are functions, and if h is a function defined by h of x equals to f of x over g of x, where g of x is not equal to 0, then if the derivative of f of x and the derivative of f g of f exists, we have this formula. The derivative of h of x is equals to the derivative of g of x times f of x minus the derivative of f of x times g of x over the square of g of x. So basically, the derivative of the second term times the derivative, so basically, so again, we have this formula. Basically, in this formula, we input the derivative of the second function times the first function minus the derivative of the first function times the second function over the square of the second function, which is the denominator. So example, to find the derivative of f of 4 x raised to the fourth power minus 3 over x plus 8. Okay, so um so first is the derivative of the second function, which is the denominator. So x is 1. Since 8 is a constant, that is going to be 0. The derivative of 8 is 0. And the derivative of x is 1. And then input the first function, or the numerator. So for x raised to fourth power minus 3 minus the derivative of the first function. So the derivative of 4x raised to fourth power is 16x cubed. So 4 times 4 is 16, and 4 minus 3 is in the exponent. 4 minus 3, 4 minus 1. So the exponent will be cube 3. And then just input the second function over the square of the second function, x plus 8. Now we're going to multiply this terms as well as this. So what we will do, so since this is just 1, we're just going to, it will remain as it is. So 4x raised to the fourth power minus 3 minus. So we're going to multiply 16x squared to this function, to this term. So times 8 times x. So it will be 16 times 1. There's always a 1 there. So it's just going to be 16, and then the x variable, we're just going to add. So again, there's for a variable, there's always a constant 1 and a exponent 1. So that is going to, if you add this x variables, the exponent of this x variables, it's going to be 4. So x raised to the fourth power. And then we're going to multiply this to this. So 16 times 16 x cubed times 8 is going to be 128x cubed. And then we're just going to retain the denominator of x plus 8 squared. The next is we are going to combine the like terms. So we have 4x raised to the fourth power minus 16 x raised to the fourth power. So that's going to be negative 12x raised to the fourth power. And remain negative 128x cubed. So as you can see here, it is positive, but since we're going to multiply this sign to this function or this terms, so that is going to be negative 128x cubed here, and then just the same, negative 3 And we're going to arrange this by the highest term. So we have 4, then 3, and then this constant. And that's it. And this is the derivative of this function. You can simplify this. And I mean, you cannot simplify this anymore. Okay, so I think this is the last rule of differentiation. So we have the power rule for negative integer powers. So this rule states that if negative n is a negative integer, and if f of x is equals to x raised to negative n, and x is not equal to 0, then the function then the derivative of f of x is equals to negative nx raised to raised to negative n minus 1. I'm sorry. So for example, we're going to find the derivative of 6 over x raised to 6 power. So what we're going to do is to bring the x raised to 6 power up. So it's going to be like this. But since this is a function, this is a fraction, if we're going to bring this denominator up to the numerator, the exponent will be negative. So 6x raised to negative 6. We're going to do is concept of the borrow. So we're going to separate the constant 6 to the variable x. And so for this, we're going to apply the power rule for negative integer. So we're going to bring down negative 6 as a constant here in the x, and then we're going to subtract 1 from negative 16, so negative 6 to negative 6. So negative 6 minus 1 is negative 5. And so that's it. And then we're just going to multiply 6 to negative 6, or to the constant. So 6 times negative 6 is negative 36. And we're just going to bring down the x raised to negative 5. So since we brought it down to its original place, so we brought it down, the variable x is going to be positive. So the derivative of 6 over x raised to the 6th power is negative 36 over x raised to the 5th power. And so that was it for the differentiation rules. Now we're going to move on to the derivative of the trigonometric functions. So these are the derivative of the trigonometric functions. Yes, you can see this is also found in the module. And now this is also it's supposed to be 1. And these are the identities of the trigonometric functions. And the purpose of these identities is to simplify the trigonometric functions. This is not found in your module, but I'm pretty sure your teacher has provided this. Okay, so take note of this. Take a screenshot, or if you have a copy, keep that in hand. Now we're going to solve some examples. Example number 1. F of x is equals to x cubed plus x. Now, what we can see here, what do you think is the rule of differentiation that we can use? It is the product rule. And so recall the formula for the product rule. So that is f of x times the derivative of g of x plus g of x times the derivative of f of x. And so this is our f of x and this is our g of x. Okay, so this is our f of x and this is our g of x. And so we're just going to input f of x, or the first function, so x cubed times the derivative of the second function, which is this. So what is the derivative of cos x? As you can see here, the derivative of cos x is negative sine x. So we have to put negative sine x plus let's input the second function times the derivative of this function. So what is the derivative of x cubed? That is 3x squared. Now we're going to multiply this and this term, this function, this term, or this term. So for this we have so we're going to multiply this, and it's going to be negative x negative x squared sine x Please ignore the handwriting. And then this is going to be, to multiply this outcome, and then we're going to multiply this. The outcome will be 3 x squared cos x. And then from there, let me arrange that. Okay. So that is the outcome when we multiply this, and this. So yes. And then as you can see, we can factor this. Factor. And we have the same variable x. And so what we can do is factor x squared. So bring it outside. And then remove what makes the other terms x squared. So like, since you're going to multiply this, factor out the x squared. So you have the x squared times negative x from negative x squared. We're going to remove x squared. So it's just going to be negative x sin x plus 3 cos x. So this 3 x squared, since we removed x squared and place it outside, it's just going to be plus 3 times cos x. And that's it. This is the derivative of this trigonometric function. Now we have example number 2. Since y equals to 1 plus sine x over x minus tan x. Now, what differentiation rule can we apply? We can apply the quotient rule. And so the quotient rule states that derivative of g of x times f of x should be minus. Let's see. Should be minus, not positive. So this is supposed to be minus. Again, the quotient rule is defined, or formula. The quotient rule is the derivative of g of x times f of x minus f of x times the derivative of g of x over square of g of x. And as you can see, this is the second term, and the derivative of the first function. So the derivative of 1 is 0, and so what is left is the positive sin x. So what is the derivative of sin x? It is cos x. So it's just cos x minus input just the first function times the derivative of the second function. So x, the derivative of x is 1, and the derivative of negative tan x. So tan x we have here is secant squared x. So since it's negative, so it's going to be negative secant squared x. And then the denominator is x minus tan x squared. Just remain it as it is. And now it's just the same. So I'm sorry for the malfunction. So we're just going to ignore the second example. I'm sorry about that, but you can answer this, of course. So this is the equation, and you can use photomath to check your answer. But photomath is a pretty trustworthy math application, so you can use that. So we're going to move on to the third example of finding the derivative of trigonometric functions. So we have this. For f of x is equals to 3. So we have 3 cosecant x plus 9 tan x minus 4 cosecant x. And so we're going to use the sum rule of differentiation. Okay, so I hope you can see the formulas. So let's recall that, as well as this, some of the identities of trigonometric functions. The solution. Okay. So we also used so for each term we used the constant multiple rule. So we separated. So we determined the derivative of cosecant x. So we had negative cosecant x times, or negative cosecant x cotangent x. So that is the derivative of the cosecant x. Plus 9 times the derivative of tan x tangent x. So we have secant squared x minus 4 times the derivative of secant x, which is secant x tangent x. For that, we're going to multiply the constant to the trigonometric function. So we have negative 3 cosecant x cotangent x plus 9 secant squared x minus 4 secant x tangent x. And that is the derivative of this trigonometric function. So let's move to the fourth example. So y equals to sine x over 3 minus 2 cos x. Okay, so obviously we're going to use the quotient rule of differentiation. So just input the second function times the derivative of the first function. So the derivative of sine x is cos x minus the first function times the derivative of the second function. So 3, the derivative of 3 is 0, and so the derivative of negative 2 cos x. So cos x is the derivative of cos x. Cos x is negative sine x. So since this is negative 2, so negative 2 cos x times negative sine x, which is the derivative of cos x, it would equate to positive 2 sine x. And then the denominator is just the square of the second function, which is 3 minus 2 cos x squared. Then we're going to multiply this. So multiply this and this. So 3 times, no, multiply this to this. Again, multiply this to this and this to this. So cos x times 3 is 3 cos x, and cos x times negative 2 cos x is equals to negative 2 cos x squared x. And then minus, let's multiply this, so it will be negative 2 sine squared x. And this remain the denominator. And then notice that negative 2 cos squared x and negative 2 sine x squared, we can factor 2. So we're going to factor out 2 times cos squared x plus 2 sin x squared. So then we're going to factor out 2 because it's going to multiply this, it's going to be negative 2 cos x squared x. And then the 2 sin x squared is going to be positive inside the parentheses, since outside the parentheses it's going to be 2. So if we're going to multiply that, it's going to be negative. Because if you're going to remain it as negative, then negative times negative is positive. So that's wrong. So I have to change this to positive to make this its original state, which is negative. So as you can see, based here in the identities of trigonometric functions, we have we can simplify cos squared x plus, oh wait, I'm going to remove this. It's just going to be cos squared x plus sine squared x. So we can simplify this simply as 1. So it is going to be 1 based on the identities of the trigonometric function. We just remove 3 cos x in the denominator, and so the derivative of this trigonometric function is 3 cos x minus 2. So again, this is going to be 1. We can simplify this using the identity of the trigonometric function. It's going to be 1. So 1 times negative 2 is negative 2. And just remove the denominator. So again, the derivative of y minus sine x over 3 minus 2 cos x is 3 cos x minus 2 over 3 minus 2 cos x squared. We're going to move on to another topic, which is the higher order derivative. So, based on its definition, if the function is differentiable, then its derivative is sometimes called the first derivative of f, or the first derived function. If the function is differentiable, then the derivative of f is called the second derivative of f, or the second derived function. And the second derived derivative of f is denoted by, that's an error, it's supposed to be f double prime. F double prime, similarly as the derivative of x, or the third derivative function, is defined as the derivative of so the third derivative of f is denoted by f triple prime. Now the nth derivative of the function f, where n is a positive integer greater than 1, is the derivative of the n-th first derivative of x. And we denote the nth derivative of f by f raised to n. Thus, if f raised to n is the ninth derived function, we can write the function f itself as f raised to 0. So basically, the higher the order derivative is about finding the derivative of a function and then finding the derivative of the derivative until the derivative is 0. So even how many times, even if it's the n becomes as high as 6, as long as the derivative becomes 0, then that's what the higher order derivative is about. So let's move on to the examples. The first example is find all the derivatives of the function f defined by f of x equals to 12 x raised to the fifth power minus 6x cubed minus 6x plus 43. So simply we're going to use the sum rule differentiation, which is wherein we are going to differentiate or find the derivative of each term. And in finding the derivative of each term, we notice that we can use the constant multiple rule as well as the constant rule of differentiation. So 12 times 5, that is going to be 60. 5 minus 1 in the exponent, so x raised to 4. And then for this function, for this term, so 16 times negative 16 times 3 is negative 48. And then 3 minus 1 in the exponent is going to be x squared. And then 6 times 1 is negative 6, and derivative of 43 is just 0. So this is the first derivative of this function. You can still find the derivative. So we're going to find the derivative or the double prime of the function. So still the constant multiple rule, as well as the power rule for positive integers powers. So 60 times 4 is 140. 4 minus 1 in the exponent is x cubed. So the derivative of 60 x raised to the fourth power is 240 x cubed. And then the derivative of negative 48 x cubed is 96x. And the derivative of negative 6 is 0. And we can still find the derivative of this function, of this derived function. So it's 240 times 3, that is 720. Then 3 minus 1 is x squared. Then derivative of negative 96x is just 96. You can still find the derivative of this derived function. So 720 times 2 is 1440. Is 1140 x, and then the derivative of negative 96 is 0. And then we can still find the derivative of this derived function. Is 1440 x is just gonna be a constant of 1440. And again, we can still find the derivative of this constant using the constant rule of differentiation, which is just going to be 0. And so the n is greater than or equal to 6. Another example is g of x is equal to x cubed minus x squared plus 1. So we can use we will be applying the rules of sum rule, constant multiple rule, and the constant rule. I mean the sum rule, positive power rule for positive integers, and the constant rule. So x cubed, the derivative of x cubed is 3x squared, and then the derivative of negative x squared is negative 2x, and then the derivative of 1 is just 0. And then we can still find the derivative of this derived function. So 3 using the constant multiple rule, and this constant multiple rule. So 6 times 2, that is 6x, and then derivative of 2x is just 2. You can still find the derivative of this derived function. Okay, so this is supposed to be at the bottom. So 6x, the derivative of 6x is just 6, and then the derivative of negative 2 is just 0. And so we still find the derivative of this function to the fourth exponent. So the derivative of 6 is 0. So the n is greater or equal to 4. Moving on to another topic is the chain rule. So based on its definition, if the function f is differentiable at, there's supposed to be an x there. So then, if the chain rule is defined as if the function f is differentiable at x, and the function f is differentiable at g of x, then the composite function f is differentiable at x sub 1. And the formula for chain rule is this one. Where we find the derivative of g of x times the derivative where we find the derivative of f, we find the derivative of f of g of x times the derivative of g of x. So what is a composite function? So a composite function is a function where there is a function inside a function. So that is what a composite function is. There is a function inside a function. So for example, as you can notice, there is as you can see from this functional example, that there is a function inside a function. So what is the first function that we are pertaining to? It is this power right here, the ninth power. That is a function. And inside this function, there is a function of this 3x squared plus 12x. So how are we going to find the differentiable or the derivative of this function? First things first is we're going to find the derivative of the first function. So then what is the first function? So again, let f of x be the first function. The first function is this. Raised to the 9th power. And so what differentiation rule we're going to apply? We're going to apply the power rule for positive integers. So then we're going to bring down 9 times this parenthesis or this constant. And then in the exponent, we're going to subtract 1 from 9. So then apply the power rule for positive integers power. And so the derivative of the first function is 9. Also, so based on the formula, the content or the content of the parenthesis is g of x. So just going to put no. So that doesn't look blank. Imagine that is g of x. Okay. Yes. Okay. So that is the function of the derivative of the first function, 9 times g of x raised to 8 to the 8th power. Now that we have found determined the derivative of the first function, we are now going to solve for the derivative of the second function. And the second function is the inside of the first of a function. So that is 3x squared plus 12x. So we're going to apply the sum rule and the constant multiple rule of differentiation. So the derivative of 3x squared is 6x, and the derivative of 12x is positive 12. So that's it for the derivative of the second function. And now we're going to input them together. Okay, so the derivative of h of x is equals to, we have to place the blood, so it's going to be, so based on the formula, we're going to input this first. So 9 times 3x squared plus 12x raised to the 8th power. Basically, it's the derivative of the first function, and then inside the parentheses is the second function, or the function inside the function, which is g of x. It is the 3x squared plus 12x. And then multiply it to the derivative of g of x, which is 6x plus 12. And so simplify it if you can, but with this function we cannot simplify this anymore because of the power, because of the exponent. Another example, oh no. So there is another formula that you can use, which is the derivative of u raised to n. So again, there is another formula that we can use for chain rule and determining the derivative of a composite function. So what is this? So the derivative of u is the n power over n u raised to n minus 1 times du. Personally, I'm using the original formula, but whichever formula you're gonna use is that you're gonna get the same answer. So just choose any formulas that you're more comfortable with or is the most convenient for you. For me, it would be the first one, but I'll also show you the second one. So we're going to. So the g of x here is the u, so that is the function inside the inside function. The inside function in the function. So that is the x squared plus 12x, and then the du, which is the derivative of u, so that is 6x plus 12, and then now we're going to input it to the formula. So n is the exponent. So n times n goes to n minus 1 times du. It's the same. That. That's it. I get the same answer. Another example is f of x equals to 4x raised to the 5th power minus 6x cubed plus 11x squared minus 8 raised to negative 4. Raised to negative 4. Oh no. Again, this is our second example for chain rule. So as you can see, oh my god. Okay, as you can see, the exponent is of negativity. So what we're going to do is to apply the what rule of differentiation. We're going to utilize the power rule for negative integers power. And so oops, that's the formula for the other chain rule, in case you forgot. So again, we're going to first find the derivative of the first function, which is the raised to the negative fourth power. Then we're going to apply the power rule for negative integers. So that is to bring down negative 4 times this raised to negative 4 minus 1. So that is going to be negative 4 times times parentheses raised to the negative 5 power. So again, inside this parentheses is gonna be g of x. Okay. Now we're going to find the derivative of the inside function or the second function. And so we're going to apply the rules of sum rule, constant multiple rule, constant rule, and constant rule. Okay, so the derivative of 4x raised to the fifth power is 20, x raised to the fourth power, then the derivative of negative 6x cubed is negative 18x squared, the derivative of positive 11x squared is positive 22x, and the derivative of negative x is negative 8 is 0. Now we're just going to input everything in formula. So the derivative of h of x is equals to negative 4 times the g of x raised to the negative fifth power times the derivative of g of x. And so we have to make sure that there is no our final answer does not contain a negative exponent. So again, we're going to apply the power rule for negative integers. And so what we did is just bring this function or the derivative of f of g of x down, so that negative the exponent negative 5 is just going to be 5, and then the numerator is just going to be the derivative of g of the derivative of g of x. And so the derivative of this chain rule is 20x raised to the fourth power minus 8. Again, the derivative of this chain rule or of this function is negative 20x raised to the fourth power minus 18 x squared plus 22x over 4 times 4x raised to the fifth power minus 6x cubed plus 11x squared minus 8 raised to the fifth power. And we have another example. Okay. So f of x is equals to 5x minus 1 over x squared raised to the 7th power. So again, let's express we find the solve for the derivative of the first function. So using the power rule of 4 positive integers. So it's going to be 7. It's going to be 7 times 3 of x raised to 6 power. And then we're going to apply the derivative of the inside function. So g of x is equal to 5x minus 1 over x squared. So we're going to use the quotient rule. And so quotient rule x squared, the derivative of 5x minus 1. So 5x, derivative of 5x is 5 and derivative of negative 1 is 0. So plus the derivative of, or plus the first function, 5x minus 1, times the derivative of the second function, or the denominator, so the derivative of x squared is 2x, over x squared squared. So we're going to multiply this and this, and so we have, we're going to multiply this and this. So x squared times 5 is 5x squared. So then we're going to multiply like this. And so 2x times 5x is 10x squared. And then 2x minus 1 is negative 2x. We don't have to multiply this, but we can. So x squared is x raised to the first power. And then, as you can see, we have a similar term. So combine this similar term. We're going to add 5x squared plus 10x squared, which will be 15x squared. And so the derivative of the g of x is 15x squared minus 2x over x raised to the fourth power. And then we're just going to come. Oh wait, okay, it's not this. Okay, so as you can see, we can still cancel, or we can still factor out the x. So it's going to out the x. So 2 factor out 1x, which is going to be x, and then x raised to 4 power, which is going to be x cubed. So this is the derivative of the g of x. It's 5x minus 2 over x cubed. Now we're just going to combine this. The derivative of the first function is the second function. So 7 times 5x minus 1 over x squared raised to 6 power times 5x over 5x minus 2 over x cubed. We can simplify this, so we're going to multiply this each function to, and we're going to apply this exponent to each of the function, the numerator and the denominator. And then we have the same or similar denominator, so we're just going to add them. So x squared, so the raised to the 6th power, that's going to be x. We're going to multiply that, so it's going to be x raised to the 12. Oh no, we're just going to add it. So 6 plus 2 is 8, and then plus x cubed is x raised to 11 power. And then we're just going to bring up 7 here. Okay, so here again, so since this is of similar variable or like terms, you can just add this. So x 5 plus 6 is x raised to the 8th power plus 3, so it's going to be x 11. So x raised to the 11th power. We're just going to bring 7 up. So 5x minus 1. So 7 times 5x minus 1 raised to 6th power times 5x minus 2. And now we can leave this as it is. But but you can also multiply the constants, and the constants are 7 and 15x minus 2. So going to multiply that. So 7 times 15x is 105x, and 7 times negative 2 is negative 14. So the derivative of the function is 5x minus 1 raised to 6th power times 105x minus 14 over x raised to the power. And that's it for chain rule. Or maybe not. So for the example, so we have f of x equals to tan z times 12 x raised to the 4th power plus 11 squared. So first things first again is we're going to find the derivative of the first function. And what is the first function here? It is the tangent times g of x. And what is the derivative of tan? That is secant squared. So the derivative of the first function is secant squared times g of x. And then we're going to find the derivative of the second function, or the inside function. So derivative of we will be applying the differentiation rules of constant multiple and constant multiple rule of differentiation. So derivative of 12 times 12x raised to the 4th power is 48x cubed, and then the derivative of 11x squared is 32x. And then we're just going to input the derivative of x and the derivative of g of x into the formula. So we have c times x secant squared times 12x raised to the 4th power plus 11x squared raised to the 16th power times 48x cubed plus 32x. And so remember that with trigonometric functions, the first term should always be a constant. And so the constant in this term, in this function, is this 48x cubed plus 32x. So the derivative of this function, of this trigonometric function is 48x cubed plus 32x times secant x times secant squared times 12 x raised to the 4th power plus 11x squared raised to the 16th power. So that's it for general. Now let's move on to another lesson, which is extreme value theorem. So this theorem states that let f be a function which is continuous on a closed and bounded interval AB. Then the extreme values maximum and minimum of f always exist, and and they occur either at the endpoints or at the critical point. So example number 1, we have find the extreme values, both the maximum and the minimum, of the given functions on the interval -2 and 2. So we have f of x equals to x raised to the 4th power minus 8x minus 1. So first is we are going to find the critical points of the function by finding the derivative of the function. So we're going to apply the different differentiation rules of power rule for positive integers, constant rule, and the constant mode rule. So derivative of x raised to the 5th power is 4x cubed, and then the derivative of -8x is -8, and then the derivative of -1 is 0. So from there, we're going to find the x value. So x 4x cubed plus 4x cubed minus 8 equals to 0. So then we're going to transpose -8 to the other side, so that will be +8. So it should be +8. And then we're going to divide 4 on both sides to cancel 4 this one, and so we're going to find the x value. Cancel that, and then this is +8. So +8 divided by +4, that is 2. So x cubed minus x cubed equals +2. We're going to find the cube root of x cubed, so that is, and also find the cube root of 2 to cancel out the x cubed. So so the cube root of x cubed is x, and then the cube root of 2 is 1.586. So now, after finding the critical points, and we can notice or observe that the critical point of the function is included in the interval -2 and 2. So that's why we're going to find the functional values including this critical point with the interval or the endpoints. And so we're just going to substitute these x values into this function. So -2 raised to the 4th power, we got minus 8 times -2 minus 1 is 31, and then this x value is -8 and 6, and then this value of 2, we have -1. And then over the values, we're going to now determine the extreme maximum and the extreme minimum values. So extreme minimum is 31, and extreme minimum, it should be -8.36. So -8.56. That is extreme minimum. So again, another example with still the same interval but different function. So critical points, find the derivative of each term using applying the rules of constant, and yes, those two rules of differentiation. And so derivative of 2x cubed is 6x squared. The derivative of negative, and also by the way, I'm just going to change. This is going to be positive, and this negative, and then this is positive, and negative. Okay. So the derivative of positive 2x squared is positive 4x, and the derivative of negative 12x is negative 12, and the derivative of 20 is 0. And then now that we have found the derivative, we're going to solve for x. As you can see, we can divide this by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. And then negative 12 divided by 2 is negative 6. As you can see, we cannot just solve the x by transposing it. By transposing negative 6 to the other side. What we need to utilize is the quadratic formula. And so, before solving for the quadratic formula, the first thing to do in solving the quadratic form in using the quadratic formula is to identify the values of a, b, and c. So it's a plus b sorry, let's do that. Okay. So yes. So those are the values of a is 3, b is 2, and c is negative 6. So we're just going to insert the values in this formula. So negative 2 plus minus square root of 2 squared minus 4 times 3 times negative 4, 6, negative 6 over 2 times 3. And now we're just going to um, um, solve. First, what is inside the radical? Square root. So 2 squared is 4, and negative 4 times 3 times negative 6 is positive 72. So we're going to add 4 plus 72, that is 76. And right now we're going to separate. As you can see, we have this value here. And so negative 2 minus the square root of 76 over 6, and then negative 2 plus the square root of 76 over 6. And then we have the critical points of x. And now we have the critical points of negative 1.79 and 1.12. And then now we're going to identify the functional values using this. And as you can see, as you can observe, the critical points of the function is included in the interval negative 2, so we are going to include this in the functional values and substitute these 4 values in this equation. And by the way, these are all wrong. Let's just erase those. So I'll be right back. Okay, so now I have arranged the f of x values. Okay, so again, substitute these x values in this equation, and then you will get these values. And then let's compare the values. And so the extreme maximum is 60, and the extreme minimum is 11.15. So that's it for extreme body theorem. So next topic we have the implicit differentiation. And so as you can see, what do you observe from this equation? This isn't the same as our this isn't the same from our examples earlier or from earlier. These are the same functions or equations. And so with this equation we cannot easily get the derivative of this function. So again, we cannot easily get the derivative of this function by using the differentiation rule, as what we have tackled earlier. But instead, we're going to use the implicit differentiation, dy over dx, or the derivative of y with respect to x. That is, yes, finding the derivative of y with respect to x. So how do we find the implicit differentiable of a function? So step 1 is to differentiate every term on both sides with respect to x. And the second step is to apply the derivative formulas to find the derivatives, and also apply the chain rule when necessary. And then step 3 is solve for dy dx, or derivative of y with respect to x. Example number 1. 2y cubed plus 4x squared minus y equals x raised to 6th power. The solution. So first find the derivative of every term. So as you can observe, with every y variable, you are going to use this variable because you are finding the derivative of y with respect to x. And with x, you're just going to use the x. So what is the derivative of 2y cubed? That is 6y squared. And then we're just going to retain this, because again, this is what we are solving for. And then the derivative of 4x cubed is 4x squared is x minus dy dx. So what is the derivative of y? Still 1. And then the derivative of x raised to the 6th power is 6 times 6x raised to the 5th power. Then after finding the derivative of every term, we're now going to transpose like terms. We have dx over dy over dx, dy dx on this side, and then x on this side. So you can see we can factor out dy dx in this side. So dy dx times 6y squared minus 1. Then just remain the function, the term on the other side. And then since we are solving we are solving for dy dx, or the derivative of y with respect to x, we're going to remove this by dividing 6y squared minus 1 to both sides. With that, we can cancel this. And also, as you can observe, we can cancel the 6 in this. So the derivative of y with respect to x is x raised to the 5th power minus 8x over y squared minus 1. And another example is this. 4x squared y raised to the 7th power minus 2x equals x raised to the 5th power plus 4y cubed. So again, we're going to find the derivative of every term. So dy dx times 4x squared y is raised to the power, so it's 4. And so right now is, since this is x and since this has x, we are going to remove this, or we're going to, yes, we're going to remove this for a while. This is going to be 4x squared times dy dx times the derivative of y raised to the 7th power, so that is 7y raised to the 6th power minus the derivative of 2x, so minus 2 equals the derivative of x raised to the 5th power, which is 5x raised to the 4th power, plus the derivative of 12 of 4y, which is 12y squared. And then we're going to transpose the like terms. So negative 2 is going to be positive 2, and then positive dy dx times 12y squared is going to be negative dy dx times 12y squared. And then after that, we are going to multiply 4 to 7. So 4 times 7 is 28, and then we're just going to combine this variable. So 4 times 28, 4 times 7 is 28, x squared, y raised to the 6th power, minus dy dx, just as it means. And now we can factor out the dy dx as both terms has it, and then dy dx times 28x squared times 28x squared y raised to the 6th power minus 12y squared equals to 5x raised to the 4th power plus 2. So again, we're finding the dy dx, or the derivative of y with respect to x, so we're going to remove this. So we'll have to cancel this. That's why we're going to divide 28x cubed, or this function, to both sides, and now we can cancel this, and then the derivative of y with respect to x is 5x raised to the 4th power plus 2 over 28x squared y raised to the 6th power minus 12y squared. And last example for implicit differentiation, this time with given points. So find the tangent line to the curve 8x raised to the 4th power plus 10y squared equals 3 at the point 1 and negative 2. So solution. First, again, is to find the derivative of the term. So the derivative of 8x raised to the 4th power is 8 is 4, that is 4, so 32, or is 32x cubed plus dy dx times the derivative of 10y squared, which is 10y, and then equals the derivative of 3, which is 0. Then we're going to transpose 32 times 32x cubed, so that will be a positive to negative 3x. It will be negative 32x cubed. And then we are going to, again, we're solving for dy dx. So we're going to cancel the dy by dividing it on both sides. So cancel that. And now the derivative of y with respect to t is negative 32x cubed over 20y. But we're not finished yet. That is not the derivative yet. So since again we have there are given points, so x is 1 and y is negative 2. What And what are we going to do with these points? We are going to substitute them with this. Substitute these values into this derivative function, derived function. And so it will be negative 32 times 1 cubed over 20 times negative 2, which is negative 45. Yes, negative 45. That's it for implicit differentiation. Now we're gonna move on to the last topic, which is related rates. So related rates is a problem in related rates is one involving rates of change of related variables. In real-world applications involving related rates, the variables have a specific relationship for values of t, where t is a measure of time. And this relationship is usually expressed in the form of an equation, which represents a mathematical model of the situation. So what are the step-by-step pattern in solving most of the related rate problems? We have step 1, to begin by defining the variable starting with t. Step 2, write down any numerical facts about y, that should be about x and y and their derivatives with respect to t. And then step 3, write down what you wish to find. Step 4, write an equation to relate x and y. And step 5, differentiate both sides of the equation with respect to t. Step 6, substitute the known values of x, y, and dy dx, or derivative of y with respect to x in the above equation and solve for dy dx. And then step 7 is write a conclusion. Okay, so first word problem of related rates is that. Okay. So a person is standing 350 feet away from a model rocket that is fired straight up into the air at a rate of 15 feet per second. At what rate is the distance between the person and the rocket increasing? A. 20 seconds after liftoff, and B. 10 minutes after liftoff. So first let us illustrate the given. So let's say this is the person, and this is the distance of which the person is standing away from a model rocket, which is 350 feet. Which is 350 feet. And now a model rocket that is straight fired up into the air at the rate of 15 feet per second. So this will be the illustration of a rocket increasing. So something like this. And this will be the distance. Okay, the distance of which the person is away. Distance between the person and the water rocket as it continues to increase up at the air. So let this be x, and let this be y. Also let this be x. Okay. So then step 1 is to begin by defining the variables starting with t. So let x be the distance a person is standing in feet away from a water rocket at ground level. So this is x. And let y be the height of which the model rocket is being fired up to the air, so this is y, the height. And then let x be the distance of a person standing. Person standing is feet away from the model rocket, being fired straight up into the air. So this. Again, this is x. And then let dy dt be the rate at which the model rocket is being fired straight up into the air. Straight up into the air. And let cz and let it should be let dz over dt, or the derivative of z with respect to t, be the rate at which the distance from the person standing away from the model rocket in the air. Okay. So again, the dz dt is the rate at which the distance from the person standing away from is the distance from the person. So which distance? Okay. Again, let dz dt be the rate at which the distance is from the person is standing away from the model rocket. So the derivative of this. Step 2 is to write down any numerical facts about x and y, their derivatives with respect to t. And so we're going to write down the first we're going to write down the given values in the problem. So we have x, which is the distance a person standing, which is the distance a person standing away from a model rocket, and that is we have 350. And then we also have the derivative of y with respect to t, which is the rate at which the motor rocket is being fired up into the air, which is 15. That's all the values that we have based on the given problem. The step 3 is write down what we wish to find. So first is we're going to find the rate of the distance between the person and the rocket increasing 20 seconds after liftoff, and the rate of the distance between the person and the rocket increasing 1 minute after liftoff. In step 4, okay. In step 4 is to write an equation to relate x and y. Now, we're going to use the Pythagorean theorem as based on our illustration, and based on the problem itself. So we're going to utilize the Pythagorean theorem. Okay, now with the Pythagorean theorem, we're going to substitute the values that we have, or we're going to find the derivative. Okay, no. We're only going to substitute the values that we have in the given problem, or that is available to us, which is x, and that is 350. So 50 squared is 122,500. And step 5 is to differentiate both sides of the equation with respect to t. Differentiate is to find the derivative. So base here, no? So what is the derivative of 2 squared? That is 2z. I mean x squared, z squared. So what is the derivative of z squared? The derivative of z squared is 2z. times 2z to p equals, so the derivative of y squared is 2y times dy of dt plus 120,500. Then we're going to differentiate it again. Actually, no. Actually, yes. Okay, so as you can see, there's 2. We can just cancel 2. And then, what is the derivative? I forgot. But it should be like this. What is the derivative of 122,500? It is 0. So again, you can cancel the 2, so it's just going to be z dz dt equals to y dy dt. And now, step 6 is we're going to substitute the known values of y, z, and dy dt in another equation and solve for dz dt. Or solve for the derivative of z with respect to t. So as you can see, in this equation, we are going to need the value of y and z, which we do not have yet as of now. That's why we're going to solve for the value of y and z. First is y, as we given naman, as we have the given of this, so it's going to be easier. So y, so also we are already solving for the for a. Okay, so y is equals to 15, or the dy of dt, 15 times 20, which is the given, 20 seconds. So that is 300, so 10 times 20 is 500. 15 times 20 is 300. So that is our y. And now for z, we're going to utilize this, and now that we have the value of y, which is 300, so 300 squared is 90,000 plus the square root of x, so square root of 350 is 122,500. And then we're going to add this 190,000 plus 122,500 is 212,500. And so we're going to get the square root of that. So z is equal to 50 and square root of 85, or approximately 460.98. So again, the y value we have is 300 and x value is approximately 460.98. And now we are going to continue the step 6. So now that we have identified the values y and z, let's see, it has to be z. That is z. So let's just substitute. So like that. 160.98 times using dt equals to 300 times 0 dt. So what I'm going to do, so again we are solving for the derivative of z with respect to time. And so we have this value, so we're just going to substitute it. So it's going to be 300 times 15. So 300 times 15 is 4,500. And now we're going to cancel 460.98. So we're going to divide that on both sides. So cancel, and then we're going to divide this. And we're going to divide 4,500 and 460.98. And so our answer for A, or the derivative of Z with respect to T, is approximately 9.76. Okay, step 7 is write a conclusion. So the conclusion for A is that the rate of the distance between the person and the rocket is within 20 seconds after liftoff is approximately 9.76 feet per second. Second, the rate of the distance between the person and the rocket increasing 20 seconds after liftoff is approximately 9.76 feet per second. Now we're going to solve for B. No, wait. Okay. Again, just repeat the step 6 since we already have the other values that we needed. But this time, since we are gonna need a different value for y and z. So still, we're just going to multiply the derivative y with respect to t, which is 15, times the given time here. So 1 minute, so we're just gonna use seconds as is what we have used here in the previous one. So 1 minute is how many seconds? 1 minute is 60 seconds. Okay, so 15 times 60, that is 900, so our y is 900. And then for y, we're going to use this, and then we substitute y, so 900 squared is 810,000. 810,000 plus 122,500, that is 932,500, and we multiply the square root of that, and then the z is 50, and 50 the square root of 370, or the z is, the value of z is approximately 965.66. And that we can now substitute the value of y and z. I think this should be z, y and z in this equation. So 165.66 times the dt equals 900 times dy dt. So then we have the value. We're going to solve for, and we have the value of dy dt, so let's just substitute that 15, so 900 times 15 is 13,500, and since we are solving for the derivative of z with respect to time, we are going to cancel this. So let's divide 965.66 on both sides. So we can cancel that, and then divide 13,500 to 965.66, and so the derivative of z with respect to time is approximately 13.98. I forgot it should be, wait, should be this kind of equal sign approximately. So again, the derivative of z with respect to t is approximately 13.98. And now the step 7 is to write a conclusion. And so the rate of the distance between the person and the rocket increasing 1 minute after liftoff is approximately 13.98 feet per second. So again, the rate of the distance between the person and the rocket increasing 1 minute or 60 seconds after liftoff is approximately 13.98 feet per second. Another example, last example. Oh no. Okay, just ignore that. So the radius of a circle is decreasing at a rate of 4 centimeters per minute. How fast is the area and circumference of the circle changing when the radius is 8 centimeters? So we're going to illustrate this given. So circle. Okay. So let's say that it's a circle. That is the circumference. It is the circumference, and the area is what is inside. And the radius is this, which is 8 centimeters. Okay. Now let's just not do this by step, but just not shortcut, but like we're not really going to have to go through this step by step. And so first is we're going to um list the values given in the equation. So we have the radius. So again, the radius of the circle is decreasing at the rate of 4. So decreasing, which means it is negative 4. I'm sorry, no, it should be, the radius is 8. So again, how fast is the area is the circumference of a circle changing when the radius is 8. So again, the radius is 8, and this negative 4 pertains to the derivative of r with respect to t. Okay. So again, the radius is 8 and the drdt is 4. But it's 4, but as you can see, decreasing. So it should be negative 4. And so what we are going to solve and find in this problem is this area and the circumference of the circle. And the first thing first is we're going to find the area. So what is the area of a circle? That is pi r squared. Now we're going to find the derivative of each term. So what is the derivative of a? That is just going to be 1. So dA dt, or the derivative of a with respect to t equals to r. So what is the derivative of r squared? That is 2r times dr dt, or and then just, so you can see we have these values. R is 8, and then dr dt is negative 4. And so we multiply that, so we get so 2 times 8 is 16, times negative 4 is negative 4 pi, and so that is the So again, 2 times 8 is 16 and 4. And now we're going to multiply 16 times negative 4. So that is going to be negative 64 pi. And so the derivative of the area with respect to time is negative 64 pi centimeters squared over per minute. So then, from centimeters to centimeters squared, because this is the area, and you know the area it is squared. That's how it is. And the unit for area is squared. So again, the derivative of the area with respect to time is negative 64 pi centimeters squared per minute. And now we're going to find the circumference of the circle, changing when the radius is 8 centimeters. So the formula for circumference is 2 pi r. So we're going to find the derivative of each thing. So the derivative of c is 1, so it's going to be the derivative of c, or the derivative of the circumference with respect to time, equals to 2 pi. 2 pi is just a constant, so it's just going to be 2 pi as it is. And then r, the derivative of r is 1. And then times dr over dt. Then we're going to substitute the values. The value of dr dt. So this is going, and we're also going to multiply 2 pi times 1. So 2 pi times negative 4. That is going to be negative 8 pi. And so the derivative of the circumference with respect to time is negative 8 pi centimeters per minute. So the conclusion, so the area and circumference of the circle is swiftly changing at the rate of negative 64 pi centimeters squared per minute and negative 8 pi centimeters per minute respectively when the radius is 8 centimeters. So the area and the circumference of the circle is negative as the radius is negative, which means as the radius of the circle decreases, the area of the circle and the circumference of the circle decreases as well. And that's it for related rates and for the whole lesson of FPBA of the basic calculus, essay 112. I hope you guys have learned something. I hope you understood the lessons better. And if not, I recommend going to YouTube and listening and watching tutorial videos there. There are many helpful videos out there regarding our lessons. And also, you can, if you want more sample problems to answer, you can also just search in Google. There's this Pulse Note, I believe that's the name of their website. They have really good problem samples and easy to understand solutions, so if you want, go check it out. And that's it for this tutorial video. Good luck at this the FPBA examinations. That's all. Thank you.